Welcome to lecture series on digital electronics under EPG Pathshala. Encoders and decoder are the most important building blocks of any digital system. Encoders are normally preferred at the input side, whereas decoders are preferred at the output side. Encoders usually convert the human readable code into binary. This binary information is processed by the digital system, and later on the binary information can be converted back into human readable form using decoders. Decoders are similar to demultiplexers, except that there is no data input. In decoders we have separate select lines. There are different types of decoders: linear decoders or binary decoders and special decoders. In binary decoders, the information which is present in the binary form enables only one of the output out of many at the output, whereas in special decoders like 7-segment display, where we need to activate more than one segment to display a 7-segment code, wherein you can see that more than one segment needs to be activated. So, special decoders can generate a code which will enable more than one segment. In this module, you will learn about the importance of decoding, how decoders can be designed, different types of decoders, and the applications of decoders in digital systems. Let us discuss the learning objectives of this module. Initially, you will understand the importance of decoders. In order to get insight into the digital system design, it is important to learn the principles of decoding. It is also important to understand the classification of decoders. We will focus on two major types of decoders: binary or linear decoders and special decoders. After learning the design principles, let us get familiar with the applications of decoders. With these learning objectives, let us begin the journey into the world of decoders. The simplest block diagram of modern digital system like calculators, mobile phones, fax machines, computers and other digital gadgets is shown here. These gadgets use binary numbers 1 and 0 for processing and storage. However, our language of communication is in the form of decimal numbers and alphabetic characters. It is difficult for human being to understand the information represented in binary. Therefore, there is a need of group of devices to convert human readable language to machine or binary language and vice versa. A digital system cannot be complete without encoders and decoders. It contains 5 basic building blocks. Keyboard and 7-segment displays are the input and output devices respectively. Encoders are used at input side and decoder is preferred at the output side. Let us now study the decoders. Decoder is a combinational logic circuit that converts a binary code into desired output signal. It is called decoder because it performs the reverse process of encoder. The process of converting binary input code into desirable output code is known as decoding. Decoder is multiple input and multiple output device with proper conversion system. A decoder has n number of input lines and m number of output lines. There are 2n possible input combinations and the number of outputs are m, which are less than or equal to 2n. Here the number of outputs can have following relation: m is less than or equal to 2n. Decoder converts an n-bit code to a single active output. The information present in one code is obtained back into desired code. In general, decoder is a circuit which converts specific code into more general form of the code. A decoder is a logic circuit which accepts a set of inputs that represent a binary number and activates only the output that corresponds to the input binary number. In other words, Decoder looks at the inputs, determines which binary number is present and activates the one output that corresponds to the given number. All other outputs will remain inactive. The basic function of a decoder is used to detect the presence of specified combination of bits on its inputs and to indicate the presence of that code by a specific output level. In its general form, a decoder has n input lines to handle n bits from 1 out of 2 raised to n output lines to indicate the presence of one or more than n bit combinations. A decoder is similar to demultiplexer without data input. The only inputs those are present are select lines or control inputs. As its name indicates, a decoder is a circuit that decodes an input code. Given a binary code of n bits, a decoder will tell which code is this out of 2 raised to n possible codes. AND gate can be used as the basic decoding element because it produces a high output only when all inputs are high. From the function table of the decoder, one can write the equations for each output. In this case, the outputs are y0 is equal to S1 bar and S0 bar, y1 is equal to S1 bar S0, y2 is equal to S1 and S0 bar, and y3 is equal to S1 and S0. The logic diagram of 2 to 4 decoder contains 2 NOT and 4 AND gates to generate the desired product terms. One can verify the truth table by providing the input conditions and checking whether the desired product term is activated or not. Let us now prepare the function table for 2 to 4 line decoder with active low outputs. In this table, 2-bit binary code selects the output by making it low. Other outputs will be high in such case. Let us now see the logic diagram for 2 to 4 line decoder. The product term in case of active low 2 to 4 line decoder indicates inversion of each output. The Boolean expression indicates the complementation of each product term. These product terms are obtained by using NAND gates instead of AND gates. Many decoders have one enable input to enable the decoding action. When enable input is low, the decoding action is activated. Otherwise, decoding action is disabled. Let us now study another decoder, that is 3 to 8 line decoder. It is also known as binary to octal decoder. The logic symbol of 3 to 8 line decoder has 3-bit binary inputs, namely S2, S1 and S0. These 3 binary inputs provide 8 possible outputs, namely Y0, Y1, Y2 up to Y7. Let us now generate the function table of 3 to 8 line decoder with active high outputs. In this table, the input is 3-bit binary code. This binary code makes only the respective output high and other outputs will be inactive, that is low. So, for example, when select inputs are 0, 0, 0, then the decoder generates only Y0 as 1 and other outputs will be 0. From the truth table, it is clear that the input binary code decides which output is to be activated. Let us now implement 3 to 8 line decoder. The logic diagram for 3 to 8 line decoder generates 8 product terms corresponding to each binary code applied at the 3 inputs. Thus, there is a need of 8 3-input AND gates and 3 NOT gates to generate the complement of input along with uncomplemented input. It is possible to verify the truth table by providing input conditions and checking whether desired product term is activated or not. In many decoders, there is an enable function, a low level on inputs E1 and E2 and a high level on the third input, that is E3, is required in order to make the enable get active high to enable this decoding action. These three enable inputs are extra other than the binary inputs. Let us now discuss the architecture of 4 to 16 line decoder. This 4 to 16 line decoder is also known as binary to hexadecimal decoder. It has 4 inputs, namely A, B, C, D, and there are 16 outputs which could be labeled as Y0, Y1, Y2 through Y15. The implementation of this decoder requires 16 AND gates and 4 NOT gates. All these outputs are active high. Similarly, we can design the scaled down version of the decoder, that is BCD to decimal decoder. In this decoder, there are 4 inputs which are labeled as ABCD and there are 10 outputs, those are labeled as Y0, Y1, Y2 through Y9. These 10 outputs are decimal outputs. In this decoder, we can have the active high or active low outputs. If we have to implement the active high outputs, so we will require 10 AND gates and 4 NOT gates for designing, whereas for active low decoder we will require 10 NAND gates and 4 NOT gates. This is the way we can implement 4 to 16 or BCD to decimal decoders. A list of available BCD to decimal decoder driver ICs in TTL logic family are shown here. All these decoders / driver ICs have active high inputs and active low outputs. The outputs could be either totem pole or open collector form. These ICs can be used either as simple indicator or a driver for Nixie tube or LED or even a relay. Let us now get familiar with special decoders. The binary decoders studied so far generates only one output out of many in response to the binary inputs to the decoder, whereas special decoder activates more than one outputs simultaneously for the applied input binary code. Many digital types of equipments require some means for displaying information. One of the simplest and most popular method for displaying numeric digits utilizes 7-segment configuration to form the numbers 0 to 9 and sometimes the hex characters A to F. Special decoders are designed to drive 7-segment displays. Each segment is made up of material that emits light when current is passed through it. Most commonly used devices include light emitting diode, that is LEDs. The 7-segment displays has 7 LEDs for segments and one additional LED for dot, which is used as decimal point. There are 2 configurations for 7-segment display. These are common anode and common cathode displays. In common anode displays, the anodes of all LEDs are connected in common and cathodes are labeled as A, B, C, D, E, F, G and DP, that is decimal point. The common anode requires driving circuit to provide low level voltage in order to activate a given segment. When low level is applied to a segment, the LED is for bias and current flows through it. In common cathode display, the cathodes of all LEDs are connected in common and anodes are labeled as A, B, C, D, E, F, G and decimal point in a sequential order. Common cathode arrangement requires the driver to provide high level voltage to activate a segment. When a high level is applied to a segment input, the LED is for bias and current flows through it. Designer can select either common anode or common cathode depending upon the application. The logic symbol of BCD to 7 segment decoder / driver has 4 inputs and 8 outputs. This BCD to 7 segment decoder generates a 7 segment code in response to binary code for driving the 7 segment display. In order to display a decimal digit, it is necessary for the decoder to activate the desired segment. Let us now prepare a table for displaying a decimal digit and a corresponding activated segments. For displaying 0, LED segments A, B, C, D, E and F must be activated and segments G and DP are off. Let us now find out activated segments for displaying digit 1. Here only B and C segments must be activated and other segments are deactivated. For displaying digit 2, LED segments A, B, G, E and D are activated. While displaying digit 3, segments A, B, G, C and D must be turned on, whereas segments B, C, F, G must be activated to display decimal digit 4. For displaying digit 5, LED segments A, C, D, F, G are to be activated. While displaying digit 6, segments A, C, D, E, F, G must be turned on, whereas segments A, B, C must be activated to display digit 7. For displaying digit 8, all LED segments A, B, C, D, E, F, G are activated. While displaying digit 9, segments A, B, C, F, G must be turned on. Let us now study the actual interfacing of BCD to 7 segment decoder driver with the 7 segment display. Here limiting resistors are connected between them. The resistor value decides the brightness of the segment. If BCD input is 0 0 0 0, then decoder generates outputs so that decimal number 0 is generated. Let us now consider another BCD input. When BCD input 0 0 0 1, then decoder generates output so that decimal number 1 is displayed. Let us now consider display of decimal number 2. If BCD input is 0 0 1 0, then decoder generates output to display a decimal number 2. Let us now study the required inputs and outputs for displaying 3. When BCD input is 0 0 1 1, then decoder generates output so that decimal number 3 is displayed. This is true for all binary codes. Let us look at the commercially available BCD to 7 segment display driver ICs. IC 7446 and 47 has open collector output and decoder requires active low output to drive the common anode display configuration of 7 segment display, whereas IC 7448 is recommended for driving common cathode display. IC 7447 is a BCD to 7 segment decoder with driver. IC 7447 has 4-bit active high BCD inputs which are A, B, C and D, and 7 segment low outputs to drive LED segments which are labeled as A through G. Please note that decimal point LED output is not shown here. In addition, this decoder has 3 additional pins. These are used for special purpose. The function of LT, that is lamp test terminal, is to test all the 7 segment displays. As it is active low input, low on this pin turns on all the LED segments of the display. In normal decoding application, this terminal should be connected to logic high. Let us now talk about BI, that is blanking input. If this terminal is connected to low level, the display is switched off irrespective of BCD inputs. This is used for conserving the power in multiplex display application. RBI, that is ripple blanking input, is connected to logic high in normal decoding application. If it is connected to low logic, then the segment outputs will generate the data for normal 7 segment decoding applications, except BCD input 0. Whenever all the BCD inputs are 0 corresponding to decimal 0, then 7 segment display is turned off. This is used for 0 blanking in multi-digit display. The RBO, that is ripple blanking output, is used for cascading purpose and is connected to RBI terminal of succeeding stage. Normally, there is a common terminal for BI and RBO in many ICs. IC 7446/47 is a TTL IC for driving common anode display as shown in this figure. Common anode terminal is connected to plus VCC. Decoder IC has open collector outputs where 7 segments are connected through the current limiting resistors. Logic circuit inside the IC converts BCD input to a required output. The current limiting resistors can be selected based on the light intensity desired by the designer. IC 7448 is a TTL IC for driving a common cathode display as shown in this figure. Common cathodes of all LEDs are connected to common ground. The decoder IC has its own current limiting resistor on the chip, so there is no need of any external current limiting resistors. Logic circuit inside the IC converts BCD input to a required output. There are many applications of decoder like leading zero suppression, multiplex display, time division multiplexing, data decoding, function generators and so on. First application of decoder is in leading zero suppression. Many 7 segment decoders have built-in capacity of zero suppression. This facility is useful in multi-digit display. This technique is used to blank out unnecessary zeros in the display. For example, number 35 is to be displayed on 4-digit 7 segment display. In place of displaying actually 0035, leading zeros will be blanked out in the display. It may help users to read the number easily. In this circuit, RBI of most significant display is connected to plus VCC and the RBO is connected to RBI of the next decoder. This is the way how ripple blanking is implemented through cascading. It is also possible to implement trailing zero suppression, in which zeros after the number are suppressed. Usually, this method is preferred when displaying a number after decimal point is 0. So, we can ignore the 0 fraction after the digit. Let us consider the next application of the decoder as multiplex display logic. In this example, a 7-segment display decoder can be used to display 2-digit data. 2 BCD numbers are applied to multiplexer inputs. Here, the multiplexer has a capacity to accept 2 4-digit binary numbers. When data select line is low, first BCD number is passed to the 7-segment decoder and generates a 7-segment code at the output of the decoder. In addition, the IC 74139, the linear decoder, enables the first display to accept data from 7-segment decoder. When data select line is high, second BCD number is passed to the 7-segment decoder and generates 7-segment code at the output of the decoder. In addition, the IC 74139, the linear decoder, enables the second display to accept data from 7-segment decoder. In this example, both binary and 7-segment decoders, that is special decoders, are used. It should be noted that the multiplexer that we are selecting is basically called 2-to-1 multiplexer. One can extend this information for 4, 8, 16 multiplex displays. In this example, let us understand the use of decoder in time division multiplexing. This time division multiplexing can also be used for timing as well as sequencing application. The TDM accepts the data from many sources and sends a selected data to the single output for transmission. Multiplexer by default should accept data from many sources and send it over transmission line to single destination. In this case, output is generated in a time multiplex manner, that is, one at a time, depending on the decoder input coming from a counter. The counter is continuously pulsed and decoder outputs are activated sequentially A, B, C, etc. This activates one relay at a time to connect the data source to the output. This is the way TDM allows sharing of common channel for data transmission. A simple computer I/O port system with a port address decoder with only 4 address lines are shown here. Decoders are used in many types of application. One example is in computers for I/O selection. A simplified computer I/O port system with a port address decoder with only 4 address lines could be designed. Computer must communicate with a variety of external devices called peripherals by sending and receiving data through what is known as input output, that is I/O ports. Each I/O port has a number called an address which uniquely identifies the I/O port. When computer wants to communicate with a particular device, it issues an appropriate address code for the I/O port to which that particular device is connected. The binary port address is decoded and appropriate decoder output is activated to enable the I/O port. Binary data are transferred within the computer on a data bus, which is a set of parallel lines. In this example, we can consider I/O ports like keyboard, video monitor, hard disk which is external hard disk. You may have a printer or any other external I/O devices. The same logic could be extended for deriving the addresses for memory devices as well. Let us consider an application of decoder in function generator, and let us use this in certain application. Any combinational logic circuit with n inputs and m outputs can be implemented with an n to 2 raised to n line decoder and m OR gates. Let us consider the procedure for designing this circuit. Step number 1, let us express the given Boolean function in the sum of min terms. Step 2, choose a decoder to generate all the min terms of the input variable. And third and last step, select the inputs to each OR gate from the decoder outputs according to the list of min terms of each function. Let us consider an example of full adder. In a full adder, the sum can be obtained as a function of x, y, z, which could be given as S is a function of x, y, z is equal to summation of min terms in bracket 1, 2, 4, 7. Similarly, one can even write the min term expression for carry as well. The carry is a function of, once again, the 3 inputs x, y, z, which is given as sum of min terms 3, 5, 6 and 7, where summation indicates sum, m indicates min term and the number in bracket indicates the decimal equivalent of the min term. Since there are 3 inputs and a total of 8 min terms, we need 3 to 8 line decoder. The decoder generates 8 possible min terms for x, y, z inputs. The OR gate for output is forms the logic sum of min terms 1, 2, 4 and 7. Similarly, the OR gate for output C forms the logic sum of min terms 3, 5, 6 and 7. This is the way one can implement any combinational circuit with the help of decoder. We can use the decoder for designing any complex logical function and a combinational circuit with the help of encoders as well as decoders. Let us now consider the other applications of the decoder, which we may not discuss in details. Decoder can be used in line coding as well as decoding for digital data communication. For line coding, usually encoder is preferred, whereas the decoding application is done by the decoder. Similarly, encoder is used for speech coding, whereas decoder can be used in speech decoding. Now, this speech coding and decoding basically generates a circuit called as vocoders, where voice coding and decoding can be done. The third application of the decoder is expansion of higher order decoder, where one may construct higher order decoder with the help of lower order decoders like 2 to 4, 3 to 8, 4 to 16 decoders. The higher order decoders like 5 to 32 and 6 to 64 can be very easily constructed using lower order decoders. In addition to that, we can use decoder for generating the memory addresses for RAMs and ROMs. This is an interesting application which is normally required for microcontroller or microprocessor based design, where each memory module can be accessed through the decoder. Let us now sum up the points that we have studied in this module. These are the most important take-home points. Decoder is the most important combinational circuit in digital system design. Decoder converts binary information into human readable form. Every digital system requires some device which is capable of converting binary information which is unknown to the human readable code. There are two types of decoders, binary or linear decoder and a special decoder. There are different types of binary decoders. Say for example, 2 to 4 line decoder, 3 to 8, 4 to 16 or BCD to 7 segment display decoder. Whereas in case of special decoder, the BCD to 7 segment display decoder or driver is normally preferred. There are many applications of decoders. This includes memory addressing, generating address for I/O devices, multiplexed data display, or it could be an application wherein we can transfer the data from one source to many. Say for example, for speech encoding and decoding or line encoding and decoding are most advanced applications. With this, we complete this module. I am signing off now. Thank you.